between time and money. If you buy an inexpensive printer, you will tinker with it. You will spend a lot of time with it. You will know it intimately. But you can also short circuit that with cash. You can go buy a $5,000 printer that comes with tech support on the phone, and the thing's going to work out of the box, guaranteed. It's just where you want to be, and there's places in between there too. It's a skill. It's like anything else. If you wanted to be a sniper, you don't go buy a sniper rifle and become a sniper. You've got to practice. Same thing with the printer. You're going to spend time printing. You'll get better and you'll get faster. My first print, I think I probably, maybe 2 or 3 hours to get the first print started. Now, we did a bullet that John shot out of his revolver.
Almost out of it.
But not
Mostly out. The end of it came out. So, it took me 5 minutes to design it, export it. I think it printed in 15 minutes out there. So that was pretty quick. It was very basic, but you get fast. You got to walk before you run on that stuff. You got to know that you're going to put in some time on it. Vocabulary. This is like any other industry that's got all these terms and crap that you got to learn and pick up on. I'm not even going to touch on a bunch of them, but these terms here for 3D printing really screwed me up because I couldn't figure out what the hell people were talking about. And this was a big thorn in my side. The additive manufacturing, really, that's the term for 3D printing. It means that you're taking a build plate and you're adding stuff to it. It's the opposite of CNC. CNC takes a block of material and cuts stuff away and reveals your part. Fused deposition modeling, that's owned by one of the companies, is trademarked. They go by that. So, and then most of the other kind of more industry-wide term is fused filament fabrication. It's all the same stuff. So don't let some of those terms mess you up. I probably spent a day on the internet trying to figure out what the hell people were talking about, if there was a difference, what it was. It was just annoying. So this is kind of my revenge on that.
So which one should we use?
It doesn't matter. Yeah.
Don't use the trademarked one and stuff you're selling.
There you go. More vocabulary. Rapid prototyping or real-time prototyping. That's more of an industry term where people are actually talking about doing this in a business. If you're wanting to get involved with it for a job, that's the term you're going to hear. So injection molding, that's the most likely alternative. Most people probably know what that is, but in case you don't, if you see anything plastic, it's injection molding. They take pellets, they dump it into a mold, they heat it up, pressure, mold pops open, part pops out. It's really strong, but not very practical. Although there are some people that are starting to do low quantity, home built injection molding, which would be pretty cool if that kind of develops later on. But that's pretty much the other technology for making plastic parts. If you've been around, heard 3D printing, you've probably heard this thing called a slicer. It's a piece of software that you use to talk to your printer. So don't let the name really throw you off. We're going to get into some more terms that are a little bit more technical. Your file types. These were very confusing for me when I started out because I didn't know which file type went where, what they did, or anything. And it's one of those things where if you had somebody to explain it to you in 2 minutes, you understand it. But if you're on your own and you got a printer set in front of you, it's like, it makes your head want to explode. So the STL file is, you can think of it, this is what you download from the internet. You download an STL file, and you just think of it as how you describe something with triangles. So everything you can think of, even a sphere, you can kind of describe it with triangles. Now those triangles may be microscopic, but they're triangles. And G code is a file that your printer reads, and it's literally like move left, turn on the plastic, move right, turn off the plastic, move over here, redo the same step. It's literally, you can look at it, it's a text file. It's just coordinates and on and offs. It's about 99% of it. The 3MF file, and again, this is, we're kind of, let me back up a second. I'm assuming that we're all going to be choosing one of the Ender printers, or Creality printers. That's what most people are going to buy. They're the best deal out there. And so some of what we're going to talk about is really geared toward those. So if you buy some other printer and you're not using the slicer I'm going to show here, you may have a little bit of a different file type, and some of this may not apply 100% to you, but you'll have something similar. So the 3MF file is basically that STL object and all your printer preferences. Like if you think when you go to print a piece of paper, you have quality, you have print front and back, you have all these different things you can tell your printer to do, black and white, color. Well, you have the same, you have a lot more of those things for your 3D printer. But that 3MF file is when you put those two together, you tell it what you want it to do, you can save that, and 6 months later you pull that thing back open, you don't have to go back in and screw with all those printer settings again. You just pull it up, it's ready to go, you slice it, send it out to the printer, and you're ready to go. So it's a big time saving. So it doesn't force you to save this file. You should. So we'll talk about that triangle model here. And what I'd like to do with this is to kind of get you guys thinking about how the printer is seeing the object that you're trying to print, what it's actually doing, what the thought process is. So we talked about that triangle model. This is the ideal model. We see a sphere. Everybody has the same kind of general idea of what a sphere is. Yeah, good. This is going to look pretty, you can see it. So this is more the triangle model here, and you can see that it's got some facets to that sphere. Now that is the STL file. You know, that's what you're going to download or generate from a 3D graphics package. And this, for math purposes, that's what the way they chose to do it. There's other ways of doing it, but typically all these printers are going to understand STL files. There are others, but this is 99% of them. The G code model. So this is that sphere, and we'll see if this is going to play. Oh, it was. It wasn't on mine.
Back.
Yeah, there we go. So that's just kind of telling you how, it's weird it doesn't show on mine. That's showing you how that it builds that layer up, a layer at a time. And on this, you should be able to see it here in a minute. It's going to stop and show you the actual movement of the print head around. Mm-hmm. And it's good to have the idea of this whenever you're getting ready to print something, because you think about that sphere, as it's going up, those sides aren't supported underneath. There's air underneath there. There are situations where you end up printing in midair. Think about a bridge. If you designed a bridge and you have to overcome that. Now, one way of doing that, you may flip the part upside down, print it upside down. So now you don't have that air underneath your print. Or you can print things called supports that go under there as you print, and then after you're done printing, you take those out. And you can have supports that are either made out of your same print material, or the real new higher end stuff is supports that are dissolvable. So you can print in 2 different filaments, you're printing this thing out, and then when you're done with it, you put it in a solvent bath, the dissolvable stuff goes away, and then you're left with the part.
Cool.
There's no place where that other filament touched it, so it's nice and pretty. Printer types. There are 2 basic ones out there. You got your HBOT. That's most of them. This is you see why it's called an H. Those are cheap. They're pretty good. And most people will be using those. There's a new style. It's not really new, but it hasn't really taken off yet. But it's much more complicated, called a Core XY. If you want to crank out prints fast, that's your buddy right there. They're expensive. They've got extra drive motors. And what the difference between these two of them, you can use your imagination. That H-bot, you got your print head. It's moving left and right, and it's moving up and down, right? But that bed that the part is setting on is moving in and out on that printer. So if you can imagine you're printing a tower and that bed's moving in and out as you're printing, it's going to shake. So the Core XY, the difference with that is the print head up top is moving around, in the XY plane, and the bed is just moving down as it prints. The other thing is your print head has got more support on that one, so it can move faster. A big deal with these things, obviously, when you build them, a lot of these are kits, they've got to be square. You've got to make sure when you're putting them together, they're square. And that Core XY can handle the mass and the forces of that thing moving faster on there, so you don't get the shake in the machine. That's another easy fix for a lot of prints to up your quality. Make sure your table doesn't wobble.
How much more is it for?
Oh man,
1,000, 5,000?
We can Google it.
you can.
That's all right.
Most of them are kits, so most of those are kits still. So yeah, you can probably get into one of those for about 1,000, I'd say. I'm not 100% sure on that because a lot of those are kits where you're buying parts and you've got to print. I think this one here, the blue stuff, is actually printed with another printer.
Ender has a 5 plus for $569.
You can, yeah, and that's some stuff we'll kind of get into later. There's some.
What did you say?
You can print the blue parts for the Core XY kit with an H-bot. So you can buy the $200 printer and print parts for your $1,000 printer. And there's you can print a lot of other stuff to make a lot of other kits too. So yeah, we'll get into some of that later on. Some other things about a printer, we kind of touched on this. The Creality Ender series is really good. They just came out with the V2 of it. I haven't used one of those, but if they're as good as the version 1, they're fantastic. Now, these things, when you put them together, one of these, sub $300 Enders, out of the box, you're going to be, if it's right and everything's good, it'll print as good as, a $5,000 printer. You can get that performance out of it with PLA. Now, once you get into more exotic materials, we'll talk about that later, it starts getting more difficult to make that cheap printer perform those higher level functions. But right out of the box, you're probably going to get really good prints out of it. The other thing is, if you like to tinker with these things, they're so customizable. I mean, literally every part on the thing can be replaced with something better. So, and that's kind of part of the fun.
Yeah.
Creativity 3D Elf Core XY 3D printer kit, $437.
There you go.
Yeah.
That's awesome. We talked about the time versus money thing for the more commercial style printers. I actually have on order a MakerBot method, and it's about a $5,000 printer. It's got a different style of print head than the Enders do. It's got a cabinet that's enclosed with a heater in it, which you need for the more exotic materials. You've got to have some way to contain heat, and this thing has a controlled heat enclosure on it. It's also got a camera in there. You can watch your print. You've got prints that are going days. And that is one rule of printing. If you do not watch your printer and you leave your printer, it will fuck up, and you will get a nest of plastic that looks like this and no part, and you'll spend the next 4 hours cleaning your printer off. It's well known. Those come with tech support. Dual heads, we talked about that, where you can do multiple different kinds of material, whether it's a dissolvable support, or you can do dual colors, do a hard plastic with a soft plastic on it. And people print shoes all the time. You use a semi-plastic with a rubber sole on it, and you just to print on a pair of shoes. Kind of reminds me of that. You guys see the Cloudy with a Chance of Meatballs? The guy sprays the shoes on. There you go. We talked about the heated chamber and how that's, and you can get all this stuff on the end. It's just a modification of it. And you know, if you're the tinkering kind and you like to be intimate with that thing and really get to know it, you can get it tweaked up and do that stuff. One of the things that people like to do is build enclosures around their enders so they can print ABS. And those little grow tents are perfect for that. Yeah.
For my shop, like that, keep out there.
Yeah. Yep. Keeps it clean. Keeps bugs out of it. You know, you've got to.
You said temperature, so you can throw a little thermostat control heater in there.
Oh, yeah.
Yeah. That's
Yep.
what I was gonna do, so I don't have room.
Yep. Well, and you know,
No more shit in the house.
prints go days.
Yeah.
So you don't want to be at 3 o'clock in the morning. You hear it downstairs. The cameras are pretty cool. Again, the enders, you can get use a Raspberry Pi, hook a camera to it. They've got a distro, I think, that you can do that. I haven't used it yet. I just really haven't had the need to. Yeah, Octoprint. From what I've heard, the people that use it, it injects a lot of issues to your prints because you've got another system over here trying to run. Let's go over some filament. Filament it's really important to know what filament that you want for something and what your printer can and can't do easily. Because you can buy some high-end filament and throw in a stock ender, and it's not going to print worth a shit. You're going to think this printer's a piece of crap. No, you fed it the wrong material. PLA. PLA is your best friend. Now, I wrote PLA Plus on here because there is a little bit of a difference between PLA and PLA Plus. PLA Plus is like $1 or $2 more a spool. Spools are typically 2 kilograms of plastic in a spool. You can print a lot of crap with it. They're about $20. And if you can, just go ahead and get PLA Plus. It's worth going out and finding that. Your prints will look better. It prints better, and you got a little bit more strength out of the material for an extra $2 spread over however many prints, probably 20 or 30. Most people are printing so small. It's biodegradable. Eventually, it is biodegradable. I've had it sitting outside for a long time, but it is corn-based. So it's not toxic or anything. You print in the house. It doesn't really, it's got a little tiny bit of a smell to it when it prints. It doesn't really stink or anything. Yeah, not quite popcorn. But you can print it if you were running one in your house. PLA is what you want to use in there. It's cheap. It's easy to print with. It's low temperature compared to a lot of the other stuff, and it's non-deforming, which means when you start printing a part, it's not going to warp on you. The reason you have a heated enclosure for other materials is because it's going to warp. ABS is probably it's the next one we're going to talk about, but it will warp on you. Where PLA, it works so well. So I know a couple of people that went out and bought printers, and the first thing they did is they went and bought some nylon reinforced filament and tried to print with it off the bat. And they used all that up, and they didn't get a single good print out of it. So PLA Plus, if I didn't say it, PLA Plus. The other thing that's really good for is prototyping. And well, we've got good durability on it. Flexibility. It's got a little bit of flex to it, which means it won't break so easily. If you get too brittle, and things are just going to crack and pop and everything, you want a little bit of flex to a lot of things that you print. The prototyping. This is where one of my big things that I tell people when they're starting to print is do prototypes. Do them, please. You will print something. It won't be right. You don't want to print it with some exotic material that takes you forever and only find out that you need to make a little tweak and redo it. When we were printing the bullets, I printed those with very little infill in them. They were almost completely hollow. So if you're building something that you want really rigid. Let's say you're, I don't know, building a block, like a Lego block or something like that. But if you're going to use it, you want it to be hollow or rigid. Print the thing hollow first. Make sure it works. Throw that one away. It took 2 seconds to print it. Go in your printer, turn your infill up, and reprint it. You'll just save yourself a lot of time because that print with no infill is going to take probably 20% of the time. And so you may have an hour print in your prototype where your main thing is going to be 8 hours long. You don't want to wait 8 hours to find out you screwed something up.
Did you say that? Sorry.
What's that?
Did you say that the PLA Plus is hard to find all of a sudden or something?
No, it's easy. It should be easy to find.
Everything on Amazon just says PLA. Does that mean PLA Plus?
No.
No. Okay.
There's a few, I was just looking, I'll get with you.
All right.
Yeah.
And it's PLA Plus.
Yeah. What's the Micro Center? I'm sure some of the bigger cities down here have a Micro Center store. They're all over the country. They carry a ton of filament, and they have typically every time I've been in one, they've got like half PLA, half PLA Plus, and you can just pick whichever one you want. It's $2 difference. Pick the other one. ABS. ABS will probably be your next. Once you get kind of going on PLA, be your next filament to use. And it does off gas when you print it, and it's pretty gnarly. I think it's toxic. I don't know, but
You've been sniffing fumes again.
I've huffed it, so I mean I can still walk, so I guess it's not that bad.
Barry's over there looking at you like, what?
There is this thumb growing out of my back. I don't know where it came from. It's cheap, and it is a lot less forgiving to print with. You've got to have some way to contain heat around your printer. And this will probably be your gateway into some enclosure when you start to do this. It is very durable. It's hard as it can be. It just loses some of that flexibility. So your PLA will flex. The ABS will tend to, if you push it, it'll crack. It's more brittle.
When you say heat around your printer, what about temperature?
Probably, they're all talking Celsius. So anywhere between about, depends on the size of the part and the material, but you're talking about between 30 and 100 Celsius. So it's warm.
Oil.
Yeah.
The bed's like 50 or 60 generally for PLA, I don't know.
Yeah. So 100 would be for more exotic stuff. But yeah. So I typically, PLA bed temperature is about, I usually run about 70 on mine. 60, depends on.
Are you talking Celsius?
Celsius.
Right now? Thanks. 86 degrees up.
Yes. Celsius.
160 degrees in American.
Yeah.
I didn't know if it suddenly switched.
Yeah, the warping situation. I can't tell you. I started printing. My oldest printer it's built. It's got a wood enclosure. It's pretty old. It's one of the first ones that came out, and I printed ABS with that for months. Could not figure out why stuff was warping, and it's in a box. And I finally figured out if I just tape some paper around it, and then it holds the heat in there, it wouldn't warp. So that was like a 3-month process getting that squared away when all it needed was some Scotch tape and a couple pieces of paper out on the printer. Yeah, I've got 4. PETG, that's water bottles. It's a clear, semi-transparent plastic. Good for outdoor use. It's, like I said, transparent, and it does not biodegrade. And it's really tough stuff. You think about a water bottle, that thing stays around for eternity, I think. I don't know, until it gets out to the Gulf somewhere. TPE is a blend of hard plastic and rubber. So you think about like a watch band. It's got a lot of flex to it. It's got a lot of strength to it too, but not a lot of rigidity. But there's enough there. So it's a really good material. TPU is semi-rigid. And these are all, as we're going through these are all harder and harder to print. They're harder to make work. Cell phone cases, I think something like that is pretty rigid, but it's got a little bit of flex to it. Nylon, in my opinion, is the end goal for me. Carbon or fiber reinforced filament. When this stuff prints, it's freaking hard, it's tough. I really think you could print some stuff with that is pretty much it wouldn't work with any of the other filaments because of the strength. It's really strong and it's really hard to print with. That should get you guys through a flash course on filaments. Software, the slicer, we talked about that earlier. And this is where a lot of the confusion is, and for me it was the hardest thing to kind of get going on. I can follow instructions or YouTube video to put a printer together. I can figure out, how that goes together. You plug it into the computer, and then it's kind of like download a file. Now what? What are you going to do with this thing? We're going to talk about the Cura slicer. It's from a company called Ultimaker, which makes printers, and they also released the slicer as freeware. I don't know if it's open source, but it doesn't matter. It's freeware. You can get it for Mac or Windows. And it's got, the good thing is a lot of people use it. It's really good, and there's a billion YouTube videos and how-tos on how to use it. Probably the worst thing about it is there's a billion YouTube videos on how to use it, and 75% of them will fuck you up. They're wrong. Yeah. So we're going to start putting that process together a little bit here. Take your STL file that you downloaded from the internet or you made. You're going to load it into the slicer, and you're going to make setting changes to your printer and tell it what you want it to do, and then it's going to output the G-code file. Now I talk about putting it on a flash drive and plugging it into the printer, and that way you don't tie your computer up to it. You can plug your printers in with the USB cable and print directly, but you're going to put that G-code on an SD card, stick it in the printer, go over there, turn the printer on, pick that file out, and tell it to go. And that's pretty much the overview of the process there.
Are there any speed requirements to the SD card around?
Just anything's going to work. It's just reading a text file is all it's doing. So you can print like 4 billion prints on one little SD card because they're so small. The slicer, this is the part I'm going to read. The slicer takes the STL object file. It incorporates printer settings and filament settings and outputs the print instructions in the form of a G-code file, which you will load into the printer on an SD card. If somebody would have told me that when I started, it would have saved me weeks of time. But that one sentence there is pretty much the process. I mean, to me, it's very confusing on how to get going on these, and I don't know why that is. Maybe it's me, I'm dense. 90% of your skill set is in that software because your print's not going to be right. You're going to want to change something, and you're going to have to change it in there. And when you get into the software and really start looking at all the settings, there's a bunch of them, and they all do different things. So there's a lot of skill set in that, and there's some pretty good tutorials on people that will tell you what changes what and what it's going to do to your print. So you'll spend a lot of time there. Notes, man, make a change, write down what you did, because you're going to come back a day later and look at that print and be like, wait a minute, what'd I do? Right? Or maybe you did it, you got 2 or 3 steps in and you thought, this isn't working, I need to back up, but you don't remember what you changed. So a notebook is priceless in this process. We'll take a look at Cura. Hopefully we can see some of this stuff. Over on the left, where we're going to look at this big white arrow. There's some buttons over there. They're kind of grayed out. You can't really see them that well, but it's just manipulating whatever object is on your print bed, flipping it around, scale, rotation, stuff like that. It's just the buttons to move stuff around on there. And all you do with an object in this is move it around, or you can duplicate it. You don't change anything in this software. The button up there at the top, you pick your printer. So you get your object in there, move it around, get it where you want. Pick your printer. The middle section there is your filament color and all your information about your filament. So that's another thing you'll do. When you buy your filament, you use a profile in this to make your filament. And so you'll set your temperature settings you want that filament to print at. They don't all print at the same temperature. So you want to pick the filament you're going to print with out of that list. There's a lot of them preloaded, the really common ones. If it's not in there, you can just copy one and make your own, but it's very helpful to kind of build that inventory up. As you got 10 different filaments sitting there, you can just go load one up and pick the one you want. The settings over here on the right are your quality settings and some of the higher level settings for your print. It's just more of a kind of an overview so you can see what's going on there. And then your slice button down at the bottom right. You'll hit that once you got everything ready to go, and that's going to generate your G code for your printer. And hopefully this video plays. Oh, nope, we're going to do this. So yeah, we kind of went through this process already. Download the STL from Thingiverse. Thingiverse is the 900-pound gorilla. They've got tons and tons of stuff to print on there. And if you can't find it, you can probably find something close and modify it, which will be your gateway into 3D design. You're going to load it into Cura, orient the object, best position. You're going to check your printer filament print settings, save that 3MF file because you want to bring it back later. And you're going to slice it, and then you're going to save the G code and load it up onto the printer. Now we get the video part. This is actually, here we're going to go. There it's going. So this is just going to take us through start to finish, from downloading something to sending it off to the printer. I picked this 4-way elbow because you can't buy it, as far as I know, at Home Depot, which is a good reason to have a 3D printer. What I'm doing here, I took a look. I'm going to go find that STL file. We're going to download it. And we're going to open it in Cura. So you don't need a really fast computer for this. This is running on my laptop. It's not super intensive. I've heard several people say, I'll start doing 3D printing when I get a faster computer. Don't need to. So what we're looking at here, I'm kind of rotating this around. You see it's mostly yellow, but there's red underneath. That's your overhang. That's where you're kind of printing out into midair. And the software, you can adjust it to figure out what angle you want to build the support under those red areas. And hopefully we'll get to, you guys will be able to see it on here. It's big enough. We're going to turn the supports on here in a second and you'll get to see it. But those red areas are areas of concern. And that's what one of the things you want to look at here, because if you start printing out in midair, there's nothing to catch your filament underneath there. So I'm going in, I'm picking my filament. I've got, this is green. It's not really that green, but I changed it to orange because that's the filament I'm going to print with.
Can you create a duck muzzle?
Yeah. I'm sure. We just need a model. So what I did here is I just did some really low quality settings. It came up at a 2-hour and 43-minute print. But I know I don't want those low settings. So I go up here and I'm going to turn it on to a higher quality. And I'm looking here at the wall thickness. I know you guys can't really see this. So I'm increasing the thickness of the shell, the outside of it, where it's going to have a little bit more strength. And all these settings, they have these tool tips. You keep seeing them pop up over there. Read those. They are helpful. Here we're checking our infill. and I go from 20 to 90% infill. So this thing's almost going to be solid. Pick a different pattern for the infill. You can read about the patterns on there, but there's different patterns that it'll print on the inside, either grids or cubic or triangles or all different things, and they have different benefits. So build plate adhesion, you can print a raft. You can print like a little, looks like a little pallet for your print sets on, if you've got something that's really hard to stick to your print bed. This has got a lot of contact. You can see when they built this thing, it's got some flat spots on the bottom, so it's really sitting on the bed nice. The supports, one of the new features in Cura is the tree support. If you guys have done some printing and haven't used tree support, you need to, because what it does, it doesn't put the support on your print. It builds it around like a tree branch growing up to support it. And hopefully we'll see it here. 9 hours and 44 minutes on this because we made those changes. Yeah, it's not fast. So here we're going to look kind of at the layering. You see these lines going up right here? Those are the tree supports. Tree supports are fantastic because supports that actually touch your print leave little marks on them, and they're kind of ugly. But other than that, and they just look cool. Little tree branches.
And so you got to go in and cut those out when you're done.
Oh, they're really thin. They're just enough to hold that plastic.
Really?
So they're super light. I mean, you can just reach in there and pull it right off.
Wow.
And we're going to kind of take a look at the layering, how the printer's building this from top to bottom. So you can kind of get an idea of, you can see those trees building up here at the edges, and then they're curving in as they go. I don't know, I'm really fascinated with tree supports, if you can tell. Yeah. Well, when you print something big, it ends up growing these huge tree forms around it, and it looks really neat. Yeah, yeah.
I'm guessing that's reusable. At that point, you can't reuse it.
Nah, you just throw it in trash. And so we just save it off to our flash card. We'll plop it in the printer and go. So that was it. That was the whole thing. We print stuff.
No clapping, but questions?
Well, no, I'm not done.
Oh,
That was
I thought you were done. Okay, yeah, sorry. I saw somebody start to clap. I'm like,
resources, and I'll make sure that this is available somehow for you guys if you want to get these resources off here. But Thingiverse is the big one. All3DP is another big site that has stuff. YouTube, there's a lot of how-tos on there. GrabCAD is another good place to get some CAD or some STL files. Pirate Bay, if you search Visibles on there, they have a filter for it, so you don't get a bunch of foreign stuff. There's a lot on there. Yeah. Google search, just put in whatever you want. Paper towel holder, STL file. You'll probably get something. Some tips. Calibrate your printer. So when you get it, it may print good. It may be 100% dead on, but you want to make sure it is. So this little guy, this little tugboat, is 3D benchy. It should be 3D bitchy, because that thing is a bitch to print if your printer's screwed up. It will screw up on that thing. But the good thing is you can print a small one, you can scale it up and print a big one, and you can really see how your printer is going to perform, because that's got all of the front, the contour where the boat's coming up there. You got a lot of stuff. You got the little dome window there with no support. You want to print it with no support, see what your printer can do. The square window is really tough. And actually the chimney on that thing is hard for a printer too, because it's making little tiny circles on that and building that up. Bed leveling. Some printers have auto bed leveling. Every single Ender printer that I've ever seen has a warped bed from the factory. I've never seen one that doesn't. I'm not saying they don't exist, but most likely your bed will be warped and it will be a bear to get your bed level, because you'll get it in level in one spot and it'll be down over here on the other one. A glass bed is the fix for that, as far as I'm concerned. Other people have other opinions. That's just mine. Bridge test, we kind of talked about that. You can see how good your printer's going to print by doing some more and more extended bridges. A heat tower. This is a good thing to have on hand to be able to print. This is one of those odd things that you can go download, and it's not an STL file. It's actually a G-code file that you'll download, and you'll load it straight into your printer. And what it does is it takes your print head and it heats it up, and it prints one section. And you can kind of see there's some numbers on here. That's at 225 degrees. And then it goes up, it cools down to 220, it prints another layer. It goes up and just keeps going down and down and down. And what you're looking for is that you can look at it and see like, well, at 200, it's the best print that I can get. Very important when you get a new filament that you do that, so you know exactly where you want that temperature to be for the filament. Just a little time taking that, setting that up. Once you get your temperature for that filament, you can go into Cura and plug all that in for your filament that you have. And now every time you want to use that filament, you just pick it out of there, and it's already going to be at the right temperature, and all the settings will be squared away.
So, question.
Yeah.
You say you want to do that before every filament.
If you get a new filament,
So, like PLA or PLA plus, but if I get a different color of the same brand of filament, I don't need to worry about it.
yeah, that's a good question. That's an excellent question. Filaments of different colors take different temperatures, even if they're the same plastic. So typically, darker temperature, more heat. What's that? Yeah, that's what I meant. Sorry. Yeah, darker color, more heat. So about maybe 5, 10, maybe even 15 degrees difference from what I've seen. So something to think about.
What about if you get a new roll of filament, same brand, same color? Would you do that still?
The good manufacturers will have a lot of consistency, but it may, if you get it and it starts not working, back up to this. Prototyping, we kind of touched on that. Low quality, less infill, maybe a scaled down version of it. PLA before you print, expensive. You can get filaments that are $300 a spool. Clearly, you want to print with your $20 spool before you really go to the expensive stuff. When you're learning, definitely prototyping. Number one problem that I've seen people have is getting their print to stick to the print bed. If it comes off during your print, you won't have anything to print to, and it's just going to start building a bigger and bigger bird nest in there. And it'll keep trying to print. It doesn't really know that it's not stuck, and it'll make a horrible mess. Most filament, well, a lot of especially PLA. PLA is very hygroscopic, so it's going to suck in moisture out of the air. They typically ship in a Ziploc bag that's vacuum sealed. Once you break that open, if you use it for a while and you're not going to use it, put it back in there. And you can also just throw them in the oven, really low temperature, let it sit in there for a while, and it'll suck some of the moisture back out of it. I did have the experience of buying a roll that was wet from the manufacturer. I don't know what was wrong with it, but you can tell when you print something, if it's very big, you'll end up with little blisters all around your print where the moisture gets hot and it makes a little vapor pocket in there. And I ended up throwing it away. It wasn't worth messing with it. Use a glass bed. We kind of talked about that. That glass, it does two things. It levels that bed. It keeps all the deviation out. So if you've got a bed that's warped a little bit, you put the glass on there, that glass isn't going to flex. It's a pretty thick piece of glass. The other thing is it's very easy to clean. With Windex on there, you're good to go. Clean print bed is important. And as that glass heats up, it dissipates the heat very well. So you get a lot of consistency in your temperature that way on your bed. Clean your print bed. Windex is your friend. I like to run my bed as hot as I can. There's a thing called elephant's foot. So if you can imagine a column sitting on that bed and it's too hot and it starts to melt at the bottom, starts to remelt the plastic, it's going to kind of ooze out and make what looks like an elephant's foot. I like to go right up to that because I like my prints to stick. And so don't be afraid of heat and figure out where your print bed temperature needs to be for your filament. Aquanet. I know.
It's not just for banks.
You spray that on your bed. It's like you're putting a nice heavy coat of paint on it, where it's on there. I really like that. You want to get the purple stuff, it's the extra hold. I don't know, I'm kind of weird. It smells good, I think, too. Could be because
As a man who lived through the 80s.
I made that. That's it. I grew up in the 80s.
That's a good way to be a little
It's probably dated yourself on that one.
So, yeah, make changes slow. Make them one at a time. Keep your notes. If you have a problem, don't be afraid to change your filament. I mean, I have fought with stuff. I told you about the one I had with moisture in it. Fought with that thing for days. Finally took it out, put another one in, and my print went like that. I like to use the UPS. My printer out here that's in the shed. If you guys don't know, it's out there. We'll start a print. You guys can go check it out. I'll start along with it. It'll run all day. UPS is good. Power blip, middle of your print. 8 hours into a 3-day print.
Oh.
3 days into a 3-day print. Let's talk about CAD a little bit. So you don't need to know it to start. So just take that off the list. But you're probably going to end up there if you end up printing a lot of stuff. Tinkercad is easy to get started in. There's a lot of tutorials. Kids can use it. It's very basic. But because of the way it's designed, it's an AutoCAD product. You should be able to build anything with enough time in Tinkercad. It doesn't have all the features that the bigger CAD programs have, but you can do that. You can build anything in it because it has all of those basic shapes that you need. The other thing about it, if you don't have a fast computer and you're trying to render out something that you've designed, it's going to kill your, it's going to be really slow. This is in a browser. So when you go to render, it's using the cloud on AutoCAD side to render your print. So, you could have literally any piece of crap computer and be able to render out a good sized print on it pretty easily. Fusion 360, I think it's probably the best move. I've tried a few other ones. They just recently disabled some of the features on it, but for somebody using the free version, it's really not going to matter a whole lot, I don't think. There's a case where I think you can only have like 10 active objects in there. So if you've got a bunch of stuff you're working on, you may have to download and save one to your hard drive to be able to start another one. But it doesn't seem like a big problem. Blender, if you guys have heard of Blender before, Blender does everything. You can do animation with it, you can do 3D design, the problem with it is there's a bajillion buttons on it, but it is open source, so if you're a diehard open source guy, you can use Blender too, and it's free. So all three of these are free, by the way. Kind of wrapping up here, we're going to talk about some next level stuff. Router tables from V1 Engineering. They have big router tables. You can buy in kits. You can print part of the thing with it. Use a Dremel as a router head on it. They even got some open images, I think, so you can just put like a 2x12 board in it and run through and engrave the whole board. Like I said, engraving, rotary engravers, or laser engravers, either one. Cutting machines, so you can cut material with either one of them. 3D scanning is another thing that is kind of a next step that you might want to take if you've got a 3D printer going, because you can scan stuff and print it. And most people now have a cell phone that's got multiple cameras on it. You can download an app and actually walk around something and get an STL file out of it. I don't know how good it is. I've never tried it, but if it's something you're not really concerned about tolerances on, like a coffee mug, you could probably scan a coffee mug.
Wait a minute.
And print it out.
If it gives you 90% there, you can finish the rest off in the software.
Sure. Yeah, absolutely. Very interesting, and those things have come down. They're little handheld ones now, and they come down way in price. I think they're under $1,000 now. Desktop CNC, that's where I'm going next. I'm very excited about those. always wanted a CNC machine, but I can't afford one that's the size of a garage. But and the desktop ones sound pretty cool. 3D printing with metal. There's kind of two ways that people are doing it now. You can buy metal infused filament, print it, and you get an object, and then you send it off to somebody, and they use a process called stintering, where they remove the filament, leave the metal, it's like this porous model, and then they replace it with metal, and then you end up with a solid model of it. It's pretty interesting. And then now they've actually got some newer, really, really high-end printers that use like a metal powder that they blow in, and it fuses it on there. And they shoot a laser on it to heat it. That's very expensive, but it's possible that it'll come down. Traditional mills and lathes. I think high technology of 3D printing is cool, but you may want to back off to regular old Bridgeport, and you can pick up a Bridgeport for nothing on Craigslist. You can find, if they're for sale, typically people will sell them really cheap. Traditional shears, brakes, sheet metal work. It's all kind of goes together. Things you can add to your toolkit: brazing, welding, soldering, and a lot of people probably already have some of these skills. So it's all just another tool in the toolbox. Just some final thoughts. I'm getting close on time. Ask on Telegram. I'm usually on there. I don't know who can do this, but I want to get a Discord channel for 3D printing on Discord.
We can just add a
Yeah.
add a channel to the
3D
existing
printing
one.
to the TSP
Yeah.
Discord. We can do that. I'm on it.
Yeah. Okay.
You got it?
If there's something that you want to know, ask me. I'm here the rest of the time. I'll help you out on it. My information's going to be on the list that goes around, so get a hold of me. Be glad to help anybody do anything. Okay, question?
Yeah, I can remember when my color printer a few years ago took 4 minutes to print a color photograph, and now it's seconds. And I love the concepts you're talking about, but the idea of taking 3 days to print out a moderately complex gadget I need on the farm makes me want to just poke myself in the eye. So, what's your educated opinion on the rapidity with which this will become something you can sit down, design something? You need a replacement couplet for a pipe. You print it, and you got it in 30 minutes.
Yeah, that's the big problem with it, and it's part of it's a physics problem. You've got a print head moving around; it can only move so fast due to the physics constraints on it. I think and like you said, it's never going to be cheaper if you're 5 minutes away from Home Depot to go buy a PVC coupling. It's never going to be that. It's the times that you can't buy the thing that you need, and yeah, it's going to take a while to print. I think we'll see speed ups. The Core XY thing will print quite a bit faster. The commercial printers, they have different print heads than the Ender, so they can force material through faster. And the other thing you can do with these to speed them up, if you don't need precision, you can get a bigger diameter print nozzle, and you can go up that way. And so you're just putting more material down on every pass and speed things up that way. So like for a rough coupling or something like that you need, yeah, there's ways to speed it up.
If you're going 3 days on a typical print and you do it that method and get a bigger nozzle, how much would it save a 3-day print?
I went from up to a 1 millimeter nozzle and did some prints with that, and I think I was probably about 50 to 60% reduction in time.
Okay.
Yeah, it's significant. Significant.
You mentioned running out of power in the middle of a print is bad. What if you run out of filament? Is that a problem, or you just turn this spool on?
You can pause a print, change filament, and keep going. And actually, the Ender printers, in theory, you can shut power off in the middle of a print, and they'll take back off and go from where they left off.
If they do
In
a
theory.
proper shutdown,
It's a good
not
theory.
a
In
power
theory,
loss.
well, no, a power loss.
Really?
Yeah. Now, have I ever seen it work right? Nope.
Let's go fire yours up, triple breaker, and see what happens.
It will start printing again, though, but it'll
Not
instead
well.
of a screwed up print. What's up?
What is the most practical type of item you've been able to print that actually has functionality or utility that you say, wow, this is worth it?
The one that really stuck out for me, I used to have a Ford Excursion with the barn doors on the back, and they have a cable lock on them, and they have a little bullet, it looks like a slip sinker that captures that cable on the inside of the door. And it's made out of plastic from Ford, and it breaks, and you can't buy one from Ford. So my doors wouldn't open. I printed this little thing about that big, put on there and fixed the door of my truck, and I thought, oh God, this is awesome. What else? I was hooked right then. Yeah. Well, I mean, for months I drove around with the doors I couldn't open, and then all of a sudden I could open them, and it literally was like 2 pennies worth of filament and a 20-minute print.
So when I'm sharing a file, when I save it to my memory card, can I just stick it into any other printer, or it has to be specifically set for that?
Specifically that one.
Okay.
Okay, we're low on time, which doesn't mean you can't still ask him questions, but I'm going to say if people need to get up, we're meeting again. Jack, where do you want to meet for your thing?
What?
Where do you want to meet for your thing in 15 minutes?
Is it next?
Oh, I thought
Publiano's
oh, Pug's next. Never mind. Meet here in 15 minutes for that if you want to go.
We'll cover that now, though.
We're gonna do.
So-
My thing will be out there.
Okay.
We're gonna do mine
By the
out.
office.
We're cleared.
Yeah.
We're
Clear?
Yeah.
We're gonna do mine out at the trailer.
Okay, so meet out there at John Pugliano's trailer in 15 minutes. I'll put a telegram out. If you want to keep asking Wade questions, that's fine. But for those of you who are like, I need to pee, go ahead and go.
Everything green's 3D printed. Anybody want to touch?
And then Jax will start at the aquaponics.
Yeah.
Huh?
PowerPoint available.
Yeah, I can get it to you guys.
Thank you, Wade.